different launches even possible, different orbits even possible in the future. Because if these are our gaps and this is what is causing a gap in NWP, then maybe we need to think about that in the future.
Okay,
Thanks.
So our next speaker is Gerard Peltzer, and he will speak on the NOAA NESDIS GNSS-R Ocean Surface Winds pilot project.
All right, good morning, everyone. I'm Gerard Peltzer, and I go by Jerry, and I'm with the NOAA NESDIS Commercial Data Program, and I support Natalie Laudier. And let's get started. So today I want to talk about the, okay, sorry. So today I want to talk about the Ocean Surface Winds reflectometry pilot. This is an ongoing pilot. Natalie just mentioned it, so it's good that I follow her. And it's also good that Spire, that VU is going to be following me, because Spire is the vendor for this pilot. And so what's the purpose of the Ocean Surface Winds pilot? So we are using commercial reflectometry data to derive ocean surface wind speeds and also to look at additional environmental measurements. So in January, we commenced the pilot study for ocean surface winds and other environmental observations. And so some of the key activities that we're doing are we're adapting ocean surface wind products that were previously developed by NOAA. And NOAA STAR had a ocean surface winds product for Cygnus data. So we're adapting that to commercial GNSS-R observations, and we're assessing their utility. We're also evaluating the vendor-derived ocean surface winds products. That's a Spire-derived product. That's their level 2 product. And then we're also assessing environmental applications for GNSS-R. And there's a whole host of them, including soil moisture monitoring, soil inundation, inland water body mapping, freeze thaw detection, sea ice detection and characterization. And as Jade Morton informed me yesterday, there's some new potential ones that are just coming out regarding ionosphere. And so we're really eager to be looking at those as well. So the pilot is really open to all environmental applications as well as ocean surface winds. So one of the key aspects of the pilot, as I mentioned, is that we're going to leverage past reflectometry research with the NASA's Cyclone GNSS, that's the Cygnus mission. So I want to mention some of the agencies that we were happy to be able to work with. We have a really broad partnership and a lot of really good people on this team. And starting with us, the Commercial Data Program, and we provide the project management. I am the project manager. So if anyone has any questions, feel free to reach me at any time. So, you know, the key participants include the NOAA STAR and UCAR and the University of Colorado, which is partnering with UCAR on this. And then the NOAA QOSAP office, and I hope I pronounced that right. That's the Quantitative Observing System Assessment Program. And then the JCSDA, which is the Joint Center for Satellite Data Assimilation. Additionally, we have partnerships with NWS, NCEP, OSPO, NCCF, and then also a really good participant, they've been very involved, is EUMETSAT and ESA, ECMWF, and then some other participants, including UK Met. So I'll talk about the vendor now. So the vendor for the pilot is Spire, and they have provided 6 months of data delivery, and that was from January through July. So the data delivery period just recently ended. And so right now we're in our period of 3 months of vendor support. And so additionally, a lot of our participants have been working with the Spire data collection from the NASA CSDA program. And so we're very happy to have that also to supplement this. So overall, this is a chart of the recent data delivery from Spire. Overall, for most of the period, Spire has well over-delivered with a brief dip due to some SpaceX launch delays and some loss of satellites. Overall, I'd like to thank Spire for really providing an excellent experience with us. They've been a great partner and have supported us at all the technical meetings. And so we've really had a good result working with them. So over on the right, I want to point out that so the products that we're getting with this include the level 1, level 1B, and the level 2 soil moisture and ocean wind products that they provide. So I'm going to start out with a chart showing some of STAR's activities. So they have been focusing on assessing the vendor data and then adapting, as I mentioned, their STAR developed ocean wind speed products to Spire data, and then investigating the utility of Spire developed wind speed products. So to date, they've fully characterized the Spire provided level 1 data, and including look at the errors and how Spire characterizes its data. They've fully characterized the level 2 wind speed product. So they validated that against other satellite and model wind data, looked at the consistency and the accuracy. They've defined some GNSS-R data sets that they're going to use in data assimilation impact studies. So one of the key things that they've done, and they've just done this, I believe that was in September 6th, or it's sorry, it was the 6th, not the 16th. So they released the first version of their ocean wind product based on the Spire level 1 data. And so their NOAA L2 Spire winds data set is providing precision geolocated average wind speed with a 25 by 25 kilometer cell size and daily global coverage from all the available Spire spacecraft. And so on the right here, you can see a chart of the NOAA derived ocean surface winds using the NOAA model. So I'll continue with some of the activities. And in these activities, I'd refer to Ben Ho for this. So some of the things their team has been working on is they've evaluated the accuracy, uncertainty, and stability of the Spire OSW data. And they've been studying assimilated GNSS-R ocean surface wind speed impacts on regional model forecasts of a tropical cyclone event. This is ongoing. And I would like to point out this, I know it's a little small here, but there's a really interesting chart showing the impact study on Hurricane Beryl, where they're looking at tropical cyclone forecasts. So they've extracted Spire ocean surface wind profiles that fall into the 12 degree by 12 degree HAFS storm following nest. And so you can see the tracks there inside those squares. I'd like to point out that as I go forward, I'm going to put in red here other presentations that are going on at IROWG related to our work here. So for more information on this, see the poster that's evaluation of Spire GNSS-R ocean surface wind through comparison with ERA5 reanalysis and JSON3 altimeter wind data. So take a look at that poster if you're interested in more. I'm going to switch to UCAR. UCAR has been incredibly active in this pilot, and their activities have focused on data assessment and various environmental GNSS-R applications. So some of their achievements to date include data assessments. They've looked at sampling coverage, quality analysis, reflectivity evaluation. They have been developing soil moisture products. So they've developed a linear regression method using Spire reflectivity observations. They're generating daily and weekly 36 kilometer soil moisture using Spire reflectivity, and that's based on a linear regression method. So they've also implemented a forward model of reflectivity to semi-physically invert soil moisture, and they've been conducting an initial experiment using data collected for Australia. And so once again, for more information, see the presentation on Monday afternoon. That's global monitoring of soil moisture using Spire GNSS reflectometry observations. And that's, I believe that's Jawa's presentation. Jawa is here, so feel free to ask him more about it. So I'm going to continue on some more UCAR activities. They have developed a method to map ground surface water and its temporal changes. So once again, for more information on this, there's a poster called Mapping Inland Surface Water using Spire GNSS reflection data. So this is a fascinating subject, and this case study was conducted using reflectivity to look at the time changes in soil inundation in a lake area in East Africa. So I'm going to give a shout out to University of Colorado, who's also been participating in this. They have a lot of good work going on. Two of their projects they're going to be presenting on Monday. And so one is remote sensing of ice shelf surface characteristics. And so feel free to see the presentation on GNSS reflectometry based mapping of Antarctic's ice shelf surface characteristics. And the second thing is the grazing angle GNSS-R carrier phase measurements for studying inland water body surface height variations and flow direction. And I looked at the abstract of this. I'm really eager to come and take a look at their presentation on Monday as well. So next, I'm going to talk about QOSAP. And for QOSAP, feel free to reach out to Lydia for more information on this. The QOSAP pilot activities include conducting impact assessments and optimization for assimilation of pilot OSW data. So I'm not going to go into detail as there's quite a lot of work going on, but basically what they've been doing is they've conducted preliminary data assimilation tests on Cygnus ocean surface wind data in preparation for working on SPIRE data. So it's kind of a preliminary work. So they've obtained some SPIRE ocean surface wind retrievals for preliminary data assimilation tests. And they've also obtained a SPIRE forward operator. So that's the operator from SPIRE. So they've conducted a preliminary test using the QOSAP original modified forward operator. So for their next steps, they want to work to better understand the Cygnus results and optimize the impact on global weather forecasting. And then they're going to develop assimilation algorithms for SPIRE data, including testing a SPIRE developed forward operator. And then they're going to quantify the impact of SPIRE data in the global weather forecasting, including some tropical cyclone evaluation. So then finally, they're going to quantify the impact of the SPIRE data in hurricane forecasting in the HAFS for a selected case. So I'm going to talk about the next steps. Right now, as Natalie pointed out in a previous presentation, that we're currently in the evaluation phase of the ocean surface winds pilot. And after the contractual phase with SPIRE ends, we're still going to be working for quite a while on analyzing the results and putting together a presentation. So we anticipate our evaluation continue through around the first quarter of 2025, at which time we're going to write a report, and that's going to go to the NESDIS AA with results and recommendations on proceeding with the second pilot in the late 2025 timeframe. So you can see here that, you know, we have it identified as a follow-on pilot occurring in the late timeframe, but the results will of course inform the NESDIS AA on whether they want to proceed with the pilot. So I just wanted to add a couple factors that are influencing our thoughts on a second pilot include obtaining data during the North American hurricane season, and that's like approximately August through November. I know that was important, but due to a lot of logistical challenges this year, we were unable to reach deep into the hurricane system, but we hope we could do that next time. And then, of course, an ability to conduct assessments and comparisons on a variety of GNSS-R data sets. All right, that's my presentation. So feel free to reach out to me. I'm Gerard Peltzer at NOAA.gov. Also, reach out to Natalie. She's the CDP PM at this time. And that's it. Thank you.
Move on to the next speaker. You have a question? Okay.
Jerry, nice talk. It's really great to see GNSS-R really advancing. Even though it's called Ocean Surface Winds Pilot, obviously there's a lot of different products, and I think soil moisture is actually one of the better products. Are you going to change the focus and broaden it, or is it still going to be very much focused on ocean surface winds?
I think that we're going to keep the focus similar because ocean surface winds has been identified as a key need for NOAA. And so while ocean surface winds remain sort of the #1 priority, the other observations are also a high priority. And remember that the NOAA pilot program, the purpose is to develop data sets that can lead to operational use. So ocean surface winds themselves may need several more iterations, may need more research to reach that state. However, there may be other uses of ocean surface, or sorry, of GNSS-R data that could relatively quickly become an operational use item. So that would justify NOAA purchasing ocean surface winds data, or GNSS-R data, sorry, for operational use, and while still researching ocean surface winds. Does that make sense? Thanks.
Good, thank you. So our next speaker is Wu and Gwen. Status on future plans of SPIRE's GNSS radio acquisition and reflectometry constellation.
All right, good morning, everyone. My name is Vu, and I'll be presenting on status and future plans